Hello. In this video, I'll be showing you how to do work, kinetic energy, potential energy, the work energy theorem, and power. Now, we are going to begin with work. Work has a formula of force times distance. Now we're going to start off with a problem of a plane called the Boeing 737 that has a mass of 85,000 kilograms, and next is going to have a force of 407,150 newtons, and then it's going to have a distance of 1,750 meters. Now, which one of these numbers do you think are we going to incorporate it to the formula of work? Force and distance, right? These two numbers right here. So we can ignore mass for this one right here, and instead we're going to multiply force times distance, which will then equal 712,512,500 joules. And don't forget to put the joules so it can be labeled as work. There we go, yeah. Yay. Now the next topic that we're going to be doing is kinetic energy. And the formula for that will be 1/2 of mass times velocity to the second power. Now for that one, we're going to use a problem of the F-16 fighter having a mass of 9,207.9 kilograms and then having a velocity of 670.56. Now this information is already provided to us, but we just have to figure out what is going to be the kinetic energy. Now, this number right here is going to be placed into m because m stands for the mass. And now for this number, it stands for the velocity, and we're going to plug it in right here into the v. So how that's going to look like is this. Now all this has to do is divide the 9,207.9 divided by 2. And now with that answer, you multiply it by this number. So we'll find the calculation for this one, and it's going to be 4,603.95. And now we're just going to solve the power of 2 for this one, which is then going to equal, and it's going to equal this number right here, 449,650.71, and now all we have to do is multiply these two numbers. Pretty simple, right? Now that answer is gonna be this big number right here. So it's gonna be about 2 billion of these joules to power this whole plane. Now that's a lot of joules in it. Now as we carry on, the next topic is going to be potential energy. Now the formula for potential energy is going to be mass times gravity times height. Now an example that we're going to use for this is the F-16 fighter, which provides us with the information that the mass is going to be 9,207.9. And now it also provides us that with the height of this, that is going to be 9,499 meters for that case, for that matter. And don't want to forget the kilograms right there. But now the mystery is this: what to put for the gravity? Well, we know that the gravity on Earth is 9.82 meters per second squared. Now that's how fast any object on Earth that is gravitational will go. Now you can see that the n per second squared, that's an acceleration. So when, say, this plane flies on Earth, the gravity that it will have while it accelerates is 9.82. Quite simple, right? Now all we have to do is incorporate these numbers into this equation. So mass into the m, this gravitational into the g, and this height into the h, and that will look like this. There it is, this right here. Now all we have to do is multiply it together, and then the answer will turn out to be this big number right here. Now that is quite long. Now that is millions right there, eh? And don't forget to put the joule sign at the end, and that is the answer for potential energy that this plane exerts on Earth. Because it's specifically on Earth due to this gravitational energy that is only on Earth. I don't know about the other planets though. Now what we're going to work on next is the work energy theorem. Now there are many equations to establish this concept. It can be usually most likely with this equation right here. Work equals the change in kinetic energy, or in other explanations it can be like this. Work equals the final kinetic energy minus the initial kinetic energy. Now the problem that we're going to be using here is a Boeing 737 plane, which is going to have a mass that is 85,000 kilograms. I have to add that there. There we go. And it's going to have a velocity of 66.9 meters per second. And we are given another information that is the distance that can be used to solve for work, although we don't know what the force is. So let me explain as to how we're going to solve this. And the distance is going to be 1,750 meters. Now for this equation, what we're going to do is we're going to solve for the kinetic energy first. So we have the mass and the velocity to help with that. So we're going to use this part of the process right here. And now we're going to later try to see if we can find the work area of it. Okay, let's begin. Now we'll start by laying out the kinetic energy, which is going to be 1/2 times the mass times the 66.9, correct? And then it's going to be squared right here. Now let us find the answer for that, and it is going to be this number right here. Now that's another big number right there. Now, since we have to find work, so this is the kinetic energy, but now we have to find work for right here. So what is work? Work is force times distance, correct? But what happens if we don't have the force, only the distance? So what's going to happen right here is we're going to put this number back down here. And since we don't have the force, we're going to have the distance be right here times the force right there, because we don't know. It's a variable that we have to solve for. So now what we're going to do to solve for this variable is we're going to divide the 1,750 divided by the kinetic energy. And from there, we'll be able to solve for the force. And this completes this whole equation of the work energy theorem, because we fill in the missing value, which is force. Now the answer to that is going to be this lovely number right here. And remember to always label it newtons for force. And that is going to be the answer for this problem, because it fulfills this variable right here. I know it may seem like a lot, but in reality, it's quite fun to solve for it. And for the final concept now, it is going to be power. Now, for this formula, it is going to be relatively simple. It's going to be this: work divided by time. Now, we know that work stands for force times distance, right? Now, we know that force times distance for the Boeing 737 is going to be this. Now, this is the work for the Boeing 737 plane. But now the time that it gives us to solve, because we want to solve the power that it exerts over a given time. Now the time is this: 54.41 seconds. So this plane is going at a rapid pace for it to be about a minute to go. Now how we're going to set it up is we're going to divide the work divided by the time right here. So 712 million divided by the 54 seconds is going to equal, now it's going to be this big number right here. Now that is a really big number. So that's going to be 13 million, and remember to label it watts. So watts is the unit for power that is going to be labeled for. So watch, imagine how many light bulbs that can power up with that many watts. Now that is going to be a lot. And we have covered all concepts of these formulas, and thank you very much for taking the time to watch this.